So like I said, we're going to be doing trigonometric proofs. Now, in order to do proofs, you have to know your identities. Now remember all the identities that I gave you on that pair. Let's put it up on the board. So trigonometry, I gave you the trigonometric identities right there. Remember that? So you need to know all of these from the start to right there, the Pythagorean identities. And then in 8.4, then we're going to start learning all the rest. Yes. Now, I'm pretty sure we know those. So why don't I do the examples in the book since you guys don't even look at the book?
I'll look at the book.
I don't.
Well, if you're absent, then you need to look at the book. Okay, let's look at example 5 in the book. It says, establish this identity. 1 plus tangent u. Now they're using u for the angle. 1 plus cotangent u is equal to tangent u. Now, first of all, what is an identity? Because what we're doing for the next 2 days, next 2 lessons, is we're proving identities. Now, what is an identity? An identity is a statement, an equation that is true all the time, no matter what. Just like these are the identities. Cosine squared theta plus sine squared theta is equal to 1. It doesn't matter what angle you plug in for theta, it's always going to be 1. It's always going to be equal. Same thing here. No matter what angle you have here for u, 1 plus tangent u divided by 1 plus cotangent u will always be equal to the tangent of u. Now what we have to do is we have to prove that. So these are the steps on how we prove identities. So first step, you take away the equal sign because we're trying to prove that they're equal. So you cannot assume that they're equal. We're trying to prove they're equal. And then you draw a line like this. Now these are the rules. You can work on the left side of the line. You can work on the right side of the line, or you can work on both. But your goal is to get the left side and the right side to be exactly the same. And if they are, that means you prove this identity. Okay, so what can you do? Does anybody see like some kind of identity that I can apply right away? Like, do I see sine squared plus cosine squared?
No.
Or tangent squared plus 1?
Yes.
That's not tangent squared, that's just tangent plus 1. See, the identity is tangent squared plus 1. That's why you gotta know your identities. And remember, you gotta be able to move around the identities. You cannot just memorize the identities like this now, cosine squared theta plus sine squared. I talked about this before. You have to be able to do this. 1 minus cosine squared theta is equal to, like, move it around. If I move this on that side, what is 1?
Tangent squared theta.
It's what?
Tangent squared
No,
theta.
there's no
Oh,
tangent.
I'm
here.
sorry, I'm sine.
Sine squared theta. You have to be able to use those identities in any form. Like here's an identity. 1 plus tangent squared is equal to secant squared, correct? So therefore, what is secant squared minus tangent squared?
1.
If I move this on that side, you can get 1. All right, now do I see anything like that here? Like I can apply something right away? No, I don't. So what do? Well, if you're stuck and you just absolutely can't see anything, one of the main techniques is change everything to sines and cosines. Because sine and cosine are like the 2 basic ones, right? Because all the other 4 can be expressed in terms of sine and cosine. So if you can't see anything that you can apply right away, change everything to sines and cosines. So what can I do with this tangent? What is tangent? Is it sine over cosine or cosine over sine?
Sine over cosine.
Okay, so sine over cosine. Now I'm remembering not this last test, but the test before. Some of you are not writing the angle here. There's no such thing as just SIN by itself. You have to have an argument here. This represents the angle. I forget who was doing it. Who was doing it?
Wasn't me.
Wait, I gotta remember to when I was correcting the papers. Dinello. Am I correct? I'm gonna figure out those tests. Check. And then, what can I change cotangent to? Cosine
Um,
over sine. You have to have the u there. And then tangent is sine over cosine. Okay, so look, everything's all sines and cosines now. So all I have to do is either change this to that or that to that, or keep working with both until both are the same now. How do you decide which side to work on? Well, usually the more complicated side, like things that you can do stuff to, like here, like this one.
Yeah.
Because when you have fractions within fractions, you can simplify that, right? Now, when you have fractions within fractions, what's the fastest way to simplify that? See, because a lot of people, you know what they do? They simplify the top, they make a least common denominator here, then they make a least common denominator for the bottom, and then when you divide by a fraction, that's like multiplying by the reciprocal. Right? That works, but here, let me show you a faster way. Like what? Okay, what if you have 1/2 plus 2/3 over 3/4 plus 1/6?
Oh, man.
What's the fastest way? See how you have fractions within fractions? We call this a complex fraction. What's the fastest way to simplify this? Now, if you want to, you can simplify this, then you simplify that, and then when you divide by a fraction, you multiply it by the reciprocal. But, yeah, that works, but the faster way is simply multiply top and bottom by the least common denominator of all the fractions you see. So look, I see 4 fractions. What's the least common denominator of all of them? 12. So simply multiply top and bottom by 12. And then in the next step, I'm not going to have any fractions. Is it legal to multiply top and bottom by 12?
Yeah.
Yeah, because that's like multiplying by 1, right? Okay, so take this 12, distribute it. 12 times 1/2. 6. 12 times 2/3. 8. See, there's no fractions. 12 times 3/4. 9. 12 times 1/6. 2. So you get 14 over 11. Bam! That's way faster than doing this multiply by the reciprocal business. Come on, now we're in trigonometry. We're on our way to higher math, so we need more efficient techniques here. So, I see fractions here. Okay, I see this now. This is like 1 over 1 and 1 over 1, right? So, what's the least common denominator of both the top and the bottom? Look. This is over 1. This is over 1. What's the least? There's like basically 4 things. What's the least common denominator of all 4 of them?
1.
No! Look, this is a So what? The least common denominator of this is 1? Thank you. It's cosine u times sine u.
Oh, sorry.
So what you do is you multiply top, we need more room. Multiply top and bottom by cosine u sine u. Oh, so Mr. Park, for this section here, we gotta be good at algebra then. Yeah! That's why they call it analytic trigonometry. Okay, now distribute. See, so if you do this, in the next step, not gonna have any fractions. Well, you shouldn't have. If you have fractions, then you did something wrong. What is this times 1? Yeah, that's a duh, yeah? Plus, what's this times this? Now, when you multiply this times this, the cosines cancel out, and what are you left with? Sine squared, right? Sine times sine is sine squared. Okay, in the denominator, what is this times 1? That's a duh. Duh! And then what is this times this? Well, when I multiply this times this, the signs cancel out,
Cosine squared.
and you get cosine times cosine, which is cosine squared. Are you guys following?
Yeah.
See, it's way faster, it's just way neater. But Mr. Park, it doesn't look anything like Dr. Trig over there. Well, we're getting there, maybe. Here we go. So what, is there anything else I can do?
Well, you have cosine or sine over cosine.
Not yet. Can I just do this? Cancel this with this? No, you only can cancel factors, right? They have to be multiplied together, not added together. So what can I do? Look at the numerator. Like, is there something I can factor out? What can I factor out from the numerator? No, look at the... Okay, let's go back to algebra 1. Holy cow, people! 3x cubed plus 6x squared. What can I factor out from those two?
3x squared.
How come now you can do it? And then what's left?
X
X
plus
plus 2. It's called factoring, people. Okay, let's do it over here. Over here I have cosine times sine. Over here is sine squared. What can be factored out?
sine.
A sine u.
Sine u.
What's going to be left? Cosine u plus sine u. See, the reason why you want to have it in factor form is so you can cancel stuff. Because you can only cancel factors. See, maybe you guys just memorize things from elementary school you guys don't understand. Like 8 over 12. How do we reduce that? Well, we change 8 to 4 times 2. We change 12 to 4 times 3. And I can cancel out the 4. Right? Because they're factors. They're multiplied together. That's when you can cancel. And that's how you get 2/3. So same thing here. Now look at the denominator. What can be factored out from both of these terms? A cosine u, and then what's left? Sine u plus cosine u. Can I cancel anything? Yes, right here, look. You got gorilla and gorilla. You can cancel these. So what's left? Sine u over cosine u. Is the left side and the right side the same? Yeah, so that's the end of the proof. And what do we write at the end to signify that we have actually proved it? Now, from what I've heard, the other teachers teach this. You make a happy face.
Oh yeah.
How do you know? Come truer.
What?
I mean, Chun.
That was 8th grade geometry.
You write a happy face?
Yeah.
Go to your room and make a happy face. The proper mathematical term is QED. Quad erat demonstrandum. Who takes Latin here? Okay. So this stands for quad, which means?
I don't know. Oh
Because, which?
no, it's not.
What? I'm just guessing.
No, it's not, dude. It's
That,
like,
right? Isn't it
It's
that?
that. No,
Not
that's
in
illa.
the
It's
verse
illa.
that.
It's illa.
Quad erat demonstrandum.
That was.
Demonstrandum.
This ain't no correct Latin.
That was.
Okay, what does that mean?
Isn't that a gerund? Is that what it's called?
Wait, what level Latin are you guys?
I'm
That's
an
a three
AP.
honors. That's a 3 honors right here,
I'm
guys.
an AP Latin. Look at
Did I tell you you could approach me?
Yeah, it's a gerund. It's a gerund.
Yeah. it's
So what does it mean? What does it mean?
What is dem?
Okay, I'll tell you what it means. That which was to be demonstrated.
That's not even correct.
It's that
Not
was
even correct.
demonstrated.
That which was to be demonstrated.
Oh.
That means we did it.
No, that's incorrect.
And if you have a hard time with this, Sarah, just remember this. Quite easily done. Quite easily done. So the other classes, they're going to make happy faces. But that's when you're a baby. We're not babies. We're growing up now. So we write the correct mathematical term. Quad erat demonstrandum. QED. Quite easily done. But you only write that if you actually do it now. So when you do your homework tonight and you get stuck, don't write that down. You only do that when you finished it. Now this is an example of a pretty straightforward one, you know.
What?
Now some people are like, what? What's it? So tonight's homework, if you look at it, I think you have 15 problems to do. They're all basic. And then tomorrow night's one, whatever the next class is, then things get kicked up a notch. Then you could have like multiple steps.
Fun.
Yeah, it is fun. Well, maybe if you think about it as fun, then maybe it'll be easier. You ever thought of that? Of course not. Okay, let's look at the next one in the book, since you guys don't even look at. See, you know when you go to college and you have to start reading your book because your professor can't speak English very well? The only way you're going to learn math is by reading the book. And you know what the best way to read the book is? You look at the examples. Then you just follow step by step. Okay, let's go to this next one here. I'm going to skip example 6 because 6 looks harder than 7. So this is example 7. Tangent, I'm just going to use theta. Tangent theta plus cotangent theta all over secant theta cosecant theta is equal to 1. So prove that no matter what angle you plug in for theta, this thing will come out to 1 no matter what. So how do we do proofs? Take away the equal sign, because we're trying to prove that they're equal.
You draw a line.
You cannot assume they're equal from the beginning. You draw a line, and you can work with the left side, the right side, or both, but you gotta get to the place where they're both the same.
So we should work.
So now look at it. Do you see any like identities like staring at you, like sine squared plus cosine squared, secant squared minus tangent squared? I don't see anything like that, right? So what do? Just like this last problem?
Break it apart.
What do we do here?
Oh, you broke it apart.
Change everything to
Sines and cosines.
sines and cosines. If you ever get stuck, just change everything to sines and cosines. Because look, there's no sines and cosines at all. So tangent is
Sine over cosine.
sine over cosine. Cotangent, we just did it back here. Cosine over sine. Whoop! Secant is 1 over. Come on, have we forgotten that already? Cosine, and cosecant is 1 over sine. Okay, so we have the same problem we had back here. We have fractions within fractions. But now that I taught you the secret, what's the fastest way to simplify this? You multiply the top and the bottom by the least common denominator of all the fractions you see, which is?
Sine times cosine.
Exactly, sine times cosine.
Is the bottom and multiplied together?
Yeah, these are multiplied. So when you have 1 over this times 1 over that, that's like 1 over cosine times sine, right? So that's why sine times cosine. See, if it was a plus, no, it would still make no difference. It would be the same least common denominator anyway. So if I take this and multiply it times this times this, the cosines cancel out, and what do you get?
Sine theta squared.
Yeah, but we say sine squared theta. This times this. The sines cancel out, and you get cosine times cosine, which is cosine squared. And some of you are thinking ahead, hey, you somebody.
Oh.
Okay, but we'll wait till the next step.
Equals 1.
Okay, now, what happens when I multiply this times this? Now, this is not a plus sign, you're not distributing it, this is time. So when you multiply this times this, the cosines cancel, the sines cancel, what's left when you cancel everything?
1.
1. Not 0 now, 1. And then, hey, you somebody.
Equals sine equals 1.
Do I really have to look at the thing? That's the most important identity there is in trigonometry. Cosine squared. This is the one you're going to be tested on the ACT, SAT, and whatever on the math level 1 test or level 2 test. You got to know that. That's 1. And then what is 1 over 1? 1. Now look, the left side is equal to the right side. So we did it. We proved it. So what do I write?
QED.
Quite easily done. Quad erat demonstrandum. Hey, that was actually easier than that one. We should have done that one first. Whatever, Danny. Okay, now here, we'll do this third example. Now this one looks the toughest of the 3. Am I going to do any more? No. This is the last example I'm going to give you. Okay, sine theta over 1 plus. Mr. Park, they're always fractions. Yeah, because it's more interesting that way. Huh? Now these are, again, these are not difficult. You wait till we learn some more identities, like the rest of the identities on the identity sheet, then we're going to get some really hairy ones. Yeah. Okay, we want to prove this identity, so take away the equal sign, make the bar. Now, there's an infinite number of ways of doing a proof now. So like we have, I don't know how many people in this class, 17 people in the class. I could give you a quiz on this, which I will, and I could see 17 different proofs. But as long as your mathematics is correct, and your left side is the same as the right side, you did the proof correctly. There is no like correct way to do it, just one correct way. There's always many ways. Okay, I'm looking at this now. This is all sines and cosines already. So what can I do with this?
Turn that in.
Change that to sines and cosines as well, okay? Because I don't see any identities sticking out at me at the beginning. So, what is cosecant?
1 over sine.
1 over sine. And then of course that's like 2 over sine then, right?
Yeah.
Now some of you are good enough, you can just go from there to there, yeah? You don't have to show all the intermediate steps. Okay, so somehow, see, that looks pretty simple as it is, right? So somehow, I have to like simplify this into that. Now, when you add or subtract fractions, what do? Okay, let's go back to elementary school. When you add and subtract fractions like that, what do? You make the least common denominator. What's the least common denominator of 3 and 2? 6. Okay, so then what's going on the top? 4 plus 3, and then you get 7 over 6, right? Same thing here. I multiplied these two, add these two fractions together. What's the least common denominator gonna be? 1 plus cosine theta times sine theta, right? Just basically that times that. Okay, what goes in the numerator though? Well, look at this fraction here. This is the denominator. What do I have to multiply top and bottom by to get this?
Sine.
So you gotta multiply top and bottom by sine, so you're gonna get sine squared theta. Okay, what about here? What do I need to multiply top and bottom by to get this denominator? Look, there's a sign there. Here's a sign. What do I need to multiply this by to get this denominator? 1 plus cosine theta. But you gotta multiply top and bottom by it, so you can get 1 plus cosine theta squared, right? 1 plus cosine theta times 1 plus cosine theta. Oh, Mr. Park, I really gotta know my algebra. Yes. Now, do you see any identities staring at you yet?
Yeah.
Not, what? What do you see? I don't see
Well,
anything.
you have a cosine and a sine, so you're setting up for.
Yeah, some of you can see the next step, right? And then hey, you somebody. Okay, I can't see anything, so we just gotta keep, just keep working with it. Now, when you see something plus something squared, can I do something with that? Yeah, multiply it out. Now, let's review some more Algebra 1. If you have a plus b squared, does everybody in here know you can go a squared plus 2ab plus b squared?
Yeah.
Or do I have to rewrite that as a plus b times a plus b and then use FOIL? I don't care what you do, you gotta be able to do that, okay? So, this is like a plus b quantity squared, so what are you gonna get when you square it? A squared plus 2ab, 2 times 1 times cosine theta, plus b squared, cosine squared theta. All I did is multiply it out, I didn't do anything. Should I multiply out the bottom, Mr. Park? No, you want to leave it in factored form because your goal is to cancel stuff, right? Because you have to cancel stuff to make it simplified like this, right? So leave it in factored form. Now some of you are thinking, yeah, but I got the parentheses here, Mr. Park. Yeah, but that's a plus sign. You cannot cancel when there's a plus sign. You only can do it when it's time. So that's why we have to multiply it out. Now, does anybody see something? Like, hey, you somebody. Right here, sine squared plus cosine squared. You somebody. We just did that right here. Look at that. That's 1. That's the most important identity we have. So sine squared plus cosine squared is 1. And so what is 1 plus 1 here?
2.
That's 2. Ooh, now it's starting to take shape. It's alive! Okay, we're almost there, people. See how it's starting to get simple? Is there anything I can factor out in the top? I'm pointing at it. The 2! Look at that 2 there, the 2 there. So if I factor out the 2, what are you going to be left with?
2.
No, you factored out the 2.
1.
1 plus... Why are we having problems with factoring, people? All over 1 plus cosine theta times sine theta. Can I cancel anything? Yeah, gorilla with gorilla. So what's left? 2 over sine theta. Hey, that's the same thing as the 2 over there. That means we're done. So how do we finish the proof? Quad erat demonstrandum. Or quite easily done. So I believe tonight's proofs that I gave you, this is as hard as it gets right here, but tomorrow night's one, then things get hairy. Well, Well, let me look, what is tonight's assignment? I'll tell you how hairy it's gonna be. So tonight's homework, 19 to 49 odd. 19, oh, the beginning ones are like, you gotta be kidding me. And you gotta go up to 49? Hey, number 49 looks almost exactly like that one right there. So that's as hard as it gets on tonight's homework. And then on Monday, we gotta go up to 7. Ooh, then it gets juicy. Then you gotta suddenly start knowing stuff. Okay, that's the lecture. Now I will pass out the test. So who did not take the test? Okay,
We'll be outside.
okay, meet me outside.